Welcome to another episode of Math with Coach Jon. And today we are going to work on solving algebraic equations with one variable. So mathletes, we're going to get started. Mathletes of the world unite. All right, so here we go. So when we say solving for the variable, okay, all that is basically we're solving for an unknown number. So in this case, we have the equation 2x plus 3 equals 9. And that right there, that x, that is the variable. That's the unknown. That's what we're trying to figure out what that is, okay? And when we say variable, almost always when you're doing algebraic equations, a variable is going to be a letter. And most common in algebraic equations, the letter is going to be an x. But they could pick any letter that they want. They could put a y, it could have been an a, it could have been a b. They could even use a symbol. It doesn't even have to be a letter. They could have put a star there. They could have put a four-leaf clover. Okay, but in this case, we have an x. So what we're trying to figure out is what that x is. So when we read this equation, what it really is saying is 2 times some kind of number. We don't know what that number is. 2 times some kind of number plus 3 will equal 9. Okay. So what our goal is, we want to have when we know we have solved this equation is when we have this. We're going to have our variable and it's going to say x equals and whatever that number is. Okay. So our problem is we got a lot of stuff happening on this side of the equal sign. So we have right here, we have a 2 and we have a 3. And right now this 2 and this 3 is keeping us from having just the x equals. Okay. So what you do in algebra, when you have numbers that you want to try to get rid of, is you always do what's called the opposite. Okay. So we're going to do what's called the opposite when we're going to try to solve this equation. Okay, so anytime you're solving algebraic equations, we need to know the opposite of a certain operation. For example, if I have addition, the opposite of addition is subtraction. Okay, if you have multiplication, the opposite of multiplication is division. Okay, and that's going to be key. We got to make sure we remember that or understand that the opposite of addition is subtraction. And the opposite of multiplication is division. That'll come into play here in a second, okay? So here we got the 2x plus 3 equals 9. We have this equal sign, okay? So on the left side of the equal sign, we want to have the x, and we want anything that's not the x to get moved over to the right side of the equal sign, okay? So whatever number is with the variable, in this case, the 2 is with the variable, we always are going to work with that last, okay? So the first thing we want to get rid of is this plus 3 has to go, okay? So we have a plus 3. And remember what we said earlier, what is the opposite of plus? Or in other words, addition. What is the opposite of that? We just talked about it before, it's subtraction. So the opposite of addition is subtraction. So to get rid of this plus 3, what we're going to do is we're going to subtract 3 on both sides. Now, a lot of people say, Coach Jon, wait, why are you subtracting 3 on both sides? The thing about math is all about being like fair. So on this equal sign, if the left side of the equal sign is subtracting 3, then the right side of the equal sign is going to be like, bro, what's up? You subtracted 3 over there. You got to subtract 3 on my side too. So it's all about being fair. Okay. And the reason we are subtracting 3, the whole purpose of it is right here, because 3 minus 3 is 0. It cancels out. Okay. And that is the reason we do that. Remember, we're trying to get rid of this 2 and this 3. So by subtracting 3 on both sides, that 3 cancels out because 3 minus 3 is 0. Okay. Now over here on the right side, we have 9 minus 3. That was 6. So right here, that was the 9 minus 3. That's how I got the 6. And when we look over here, we still got this 2x. So I'm going to write that down. All right. So here's what we've done, mathletes. We started with 2x plus 3 equals 9. And our first step was to subtract 3 on both sides. Okay. And that left us with just 2x equals 6. All right. So now what we're trying to do is we're trying to get rid of this 2. Okay. Because once we get rid of that 2, we will have what we're looking for, x equals. Okay. Now here we have the 2 and the x. They're stuck together. Anytime you have a number and a variable stuck together, you don't see, there's no plus sign, there's no minus sign. They're just stuck together. Anytime you see that, that means they are being multiplied. So when you see 2x, what that really is saying is 2 times x. That's what the operation that's happening there. Okay. So to get rid of that 2, remember, we got to do the opposite of the operation that's happening. So if this is 2 times x, the opposite of times or the opposite of multiplication is division. So to get rid of that 2, we're going to divide. We're going to divide both sides by 2 because remember, we got to do both sides because again, math, it's all about being equal. If I divide by 2 on the left side, I got to divide by 2 on the right side as well. Okay? The whole reason we're dividing both sides by 2 is right here because 2 divided by 2 is 1. So basically those 2's cancel out because you don't have to write 1. You could just keep it as, okay? So basically the only thing that survived there was just that x. And then when we look here, I have 6 divided by 2. And 6 divided by 2 is 3. And then at that point, you have done it. You have solved that equation. So when we had the beginning equation, it started off 2x plus 3 equals 9. X has to be 3. And if you wanted to double check yourself, you could. You don't have to do this, but if you just want to double check and see, did I do it correctly? If we substitute, it says x equals 3. So when I look at that original equation, the original equation, I'm going to rewrite it, was 2x plus 3 equals 9. We know that x is 3 because we solved for that. So I'm going to substitute that x with a 3, and then I'm going to rewrite everything that we had. And so when I do right here, remember this is multiply, say 2 times 3 is 6, okay? And then 6 plus 3 is 9. 9 equals 9, that checks. All right, so first question is in the books. Now we're going to go to our second question. Now this one is going to be a little trickier, okay? The first question we did, there was the x and it was only like one x in the entire problem. But here, if you notice, I got an x over here, still one variable. We're still dealing with one variable. It's the x. However, I got a 4x on the left side of the equal sign, and I got a 2x on the right side of the equal sign. So now I'm having all kinds of issues. I got a 4x over here, a 2x over here. And then as far as when I say a regular number, I just mean a number that doesn't have a variable. So when I look at a -5 and a +9, they're on 2 separate sides. And remember, what we're trying to do is we're trying to get the x on one side of the equal sign and everything else on the other side of the equal sign, okay? So what we're going to decide to do here is let's get our x's to the left. So let's do that first, okay? So this 2x, I want to move over to the left side of the equal sign, okay? So to do that, remember, we're working with the opposite. So for example, if it's a positive number, the opposite of addition is subtraction. And remember, the opposite of multiplication is division, okay? Now this is going to be really important. I want this entire 2x to move over to the other side, okay? I'm not trying to keep the x, but get rid of the 2. I need the whole entire 2x to go, okay? So because I'm not trying to break the 2 and the x apart, I want them to stay together. All that means is to do that, since this is a positive 2x, we're going to subtract 2x on both sides, okay? And by doing that, the reason we do that is right here. 2x minus 2x is 0. That cancels out. And then over here on the left side of the equal sign, 4x minus 2x is 2x. Now I still got that -5. I'm going to write that down. And then I still got that 9 there in the back. Okay. So I got my 2x minus 5 equals 9. Now, remember, like we did before, our final answer, we're looking for it just to say x equals. So right now when I'm looking, I got a 2 and I got a -5. Okay. I got to get rid of those because I only want the x to stay. The other 2 got to go. So what we're going to do here is we're going to get rid of that -5 first, okay? And since it's a -5 or a -5, the opposite of a negative or the opposite of subtraction is addition. So to move that over to the right side of the equal sign is I'm going to add 5 on both sides. And again, the reason we do that is -5 plus 5, or in other words, 5 minus 5 is 0. That cancels out, okay? So all that will be left on the left side of the equal sign is just a 2x. Okay. Now over here, I can't forget to add those together. That 9 plus 5, that's 14. All right. So here we go. So now all we have left is just the 2x equals 14. And the last step to solve this problem is to get rid of that 2. Okay. Now earlier, when I wanted to move the entire 2x over, that was more of an addition and subtraction situation. But here, I want to split that 2 and the x apart. I want the x to stay, but I want the 2 to go, okay? So what that means is these are basically being multiplied, and the way to split them apart is to divide, which makes sense because that word divide means to basically split apart. If I'm trying to, divide, something up, I'm splitting something among people. Okay. So to split this 2 and the x apart, we're going to divide. So that we're going to divide both sides by that 2. Okay. And the reason we do that again is 2 divided by 2 is basically 1 or 1 whole. So those cancel out. And all that will be left there is that x. And then over here on the right side of the equal sign, 14 divided by 2 is 7. And there you go. You just solved it. All right. So going on, mathletes, we got 2 more questions. We're going to hang in there. We can do this. Okay. So now this one, most people, when they see a problem like this, they'll just say, Coach Jon, nope, not happening. There's fractions. Fractions are just evil. I'm not going to lie. I love math. Fractions, they can be a little evil sometimes. Okay. But don't panic. We're going to solve these just one step at a time. So we got this. Okay. Now, like the question we just did, we have a variable. It's the same variable. In this case, it's an A. It's not an X this time. We got the variable A. We're solving for A. We're trying to figure out what A will equal. That's what we're trying to figure out. So what we want to do is we want to get our A's on one side of the equal sign and our whole numbers are the numbers that don't have a variable on the other side. So here's what we're going to do. We're going to take this A over 4, that entire A over 4, we're going to take that all over to the left side of the equal sign. Okay. So to do, that's going to be either addition or subtraction. Now, because that A over 4, there was no negative sign or anything like that, that means it's positive. And remember, the opposite of a positive or the opposite of addition is subtraction. Okay. Just to review, opposite of multiplication is division. Just remember that. So to get rid of that A over 4, to bring it over, what we're going to do is we're going to subtract A over 4 on both sides. And when we say A over 4, sometimes mathletes, if you need to see it, you can put the 1 there. If you want to put 1A, just because it makes it a little easier to tell that's the number 1. Okay, but on the right side, this A over 4 minus A over 4, the great thing about that is that cancels out. See ya. A over 4 is gone. Okay, so that means on the right side of the equal sign, the only thing we have left is that -5. Okay. Now over here, we got a lot going on. I got a 2A over 4 minus 1A over 4. Okay. Now remember, when you subtract or add fractions, they got to have a common denominator. In this case, it worked out perfect. They both have a 4. And remember, a denominator is just simply the number at the bottom of a fraction. Okay. So I have 2A over 4 minus 1A over 4. Okay. So they have common denominators. So these are actually ready to subtract. And so all you do when you subtract fractions, once they have a common denominators, we're just going to subtract the numerators, or in other words, the top numbers. So 2A minus 1A is just 1A. Okay. And then remember, when you subtract or add fractions, the denominator will stay the same. Okay. And then if you look over here, we also had a +3. So I'm going to write that over here. Okay. So I have a 3 that was right here. That was still left in there. We have the 1A over 4 that we got when we subtracted the 2A minus 1A over 4. Okay. And then over here on the right side, we had that -5. Okay. So here we got a crazy problem. I got 3 plus 1A over 4 equals -5. Now remember, when we're going to get to that last final solution, that A equals, so we're going to worry about the 1 and the 4 and that A last. Okay. So the first thing we want to do is get rid of that 3. Okay. Now that 3 is a positive number. Okay. We know that because there's no sign. If there's no sign in front of a term, then that means it's positive. Okay. So the opposite of a +3 would be a -3. So what I'm going to do is subtract 3 on both sides. Okay. And of course we do that because 3 minus 3 is 0. Gets rid of that. Okay. So on the left side of the equal sign, the only thing we have is 1A, or in other words, instead of saying 1A, I'm just going to say A, and we had 4 at the bottom. Okay. And that's going to equal the answer that we get when we say -5 minus 3. Now, another part that makes this difficult, mathletes, is the negative signs. Okay. If this was this is working with integers, and integers is just simply a whole number that is either a positive or a negative number. So here I have a -5 and I have a -3. Now, if we notice, the 5 has a negative and the 3 has a negative. That means these numbers have the same sign. Anytime you're adding or subtracting numbers, when they have the same sign, same means add. So what we're going to do here is we're actually going to add and keep the sign. So a -5 minus 3 would equal a -8. Okay. So anytime you got two numbers, whether it was two positive numbers, if this was a +5 and a +3, we would add them together just to be 8. If they have the same sign of their negatives, in this case like this, a -5 and a -3, we would combine them to be, -8. All right, so we're almost there. So I have a divided by, and remember a fraction, that sign, that fraction right there is basically means division. Okay, so when you say a over 4, or is really saying a divided by 4. So my problem is I want to get rid of this 4 because remember, I just want the a. I want it to be a equals. So right now what's getting in our way is this 4. The 4's got to go. So what's the opposite? So this is being divided, a divided by 4. What's the opposite of division? Multiplication. So if I multiply both sides by that denominator, that 4, I'm going to multiply both sides by that 4. The reason we do that is because 4 times 1/4, the 4s are going to cancel out. And again, that's always why we do the opposite, because we'll cancel those out. So the last thing we have on the left side of the equal sign is just a. And then over on the right side of the equal sign, I have a -8 times 4. Okay, so I have a negative number being multiplied by a positive number. And when we do that, a negative times a positive is a negative. So in this case, our final answer would just be a equals -32. Going on to our last question. Okay, so here, I know we'll probably have a round of applause because there's no fractions. I get it. But here we have 3x plus 4 equals 5x minus 6. So again, one variable, we're working with just the x's. But like before, we have an x on the left side of the equal sign, and we have an x on the right side of the equal sign. So what we want to do is we want to get those x's together. So what I'm going to do is I want to take this 5x and I'm going to bring it over here to the left side of the equal sign. And to do that, since this 5x, there's no negative or positive in front of it, so that means it's a positive number. So the opposite of a positive number is a negative. So I'm going to subtract 5x on both sides. Okay. And remember, so now I do that because 5x minus 5x cancels out. That's gone. So that means the only thing on the right side of the equal sign here is a -6. Okay. We still got this plus 4 here. Okay. But now I got to combine like terms here. I got to say 3 minus 5. So here, this is where it gets a little tricky here. So I got a +3 and a -5. So I'm subtracting these numbers. Okay. And I know that normally if I said 5 minus 3, that would just be a 2. But in this case, the 5 is negative. So what's going to happen is 3 minus 5 is actually going to give you a -2x. Okay. Because this was a +3 and that was a -5. They have different signs. It's a positive. They're not going to write a positive like sign, not going to do that here. But basically that 3x is a positive number and the 5x was a negative number. And anytime you got numbers that have different signs, different means subtract. So that's why we knew we had to subtract these. So I just look, I know that 5 minus 3 is 2. And when I look at these numbers, whatever number is bigger, in this case, a 5 is bigger than a 3, we take the sign of the bigger number. Okay. So 3 minus 5 would be -2x. All right. So here we go. So I have a -2x plus 4 equals -6. Now, mathletes, if you have any questions about subtracting positive and negative numbers, if working with integers gets really tricky, like if it's a -5 minus 6 or 2 minus 8, if you're not comfortable with that, don't worry. We'll have videos about how to work with integers and adding and subtracting positive and negative numbers. So don't worry, we'll have that video for you as well. So if you need to practice on that skill, don't worry, we'll have that available too. We'll work on that specific skill too if you need extra practice. Okay, so back to the equation here. We have a -2x plus 4 equals a -6. Okay, so right now I got to get rid of this -2 and I got to get rid of this +4 because again, all we want is x. We want it to be x equals. Okay, remember the number with the variable, we're going to do last. So the +4 has got to go. We got to get it to the other side. So the opposite of a plus is a minus. So we're going to subtract 4 on both sides. Okay, 4 minus 4 cancels out. That's 0. Okay, now I still have a -2x here. That's all that's left on the left side of the equal sign. But when I look here, I have a -6 and a -4. Okay, now we check it out. We got the same sign. These are both negative numbers. And so anytime you got two numbers with the same sign, same will mean add. So -6 minus 4 Same, we're going to add and keep the sign. So -6 minus 4 gives us a -10. Okay. So here we go. We're almost there. So I got a -2x equals a -10. Last step to solve this problem is to get rid of that -2. And remember, we want to split these apart. We want to keep the x, but we want to get rid of the -2. We're trying to split these apart. So that means we're going to divide because these are being multiplied. The opposite would be division. So I'm going to divide both sides by -2. Now a -2 divided by a -2 cancels out just to be 1. So all we have left over on the left side of the equal sign is just the x. And then on the right side of the equal sign, I have a -10 divided by a -2. Now a negative divided by a negative is a positive. So we know our answer is going to be positive, and 10 divided by 2 is 5. So you've done it. All right, Mathletes, great job. You did. We had 4 questions solving algebraic equations with a single variable. So great job. Really proud of you. Just remember, be patient. This takes practice, but sooner or later, you'll be solving these without even thinking. It'll just be second nature. But if you could hit that subscribe button, if you want to hit that notification bell for future episodes, please do. And we'll talk to you soon.